today we'll be talking about the combination circuits. Earlier in last lectures we talked about both parallel and series circuit. I hope we brush up with that and we know what a series circuit is and what a parallel circuit is, because in combination circuits we will use both of them. So let's a little bit recap that and review that a little bit. In a series circuit we have three rules: that current stays the same in every point of the circuit. So that will be IT will be equal, the total current supplied will be equal to I1, current it's resistor number 1, current and resistor number 2, and so on. And the voltage drop in a series circuit will be the sum of all the voltage drop should be equal to the voltage supplied. And we add resistors as just simple addition, no fraction in there, is just for instance will be R1 plus R2 plus R3 will equal to RT. And in the other hand, parallel circuits have different properties. In this one, in the parallel circuit, the voltage will stay the same in every branch, while the current is different. And the current will be the sum of individual current should equal to the supplied or I total current. And yes, so we do have three methods of adding the resistors. There'll be, if you have two resistors like R1 and R2, and they have the same value, for instance 20 ohms, and what we will do, that to find the total resistance of that will be, we will pick one of these and divide by 2, because we have two of them, will be give us 10 ohms will be the answer. But if we have not the same resistors, then we have two other ways to do it. One is the product over addition, and the third one is the famous one or the original one, or the general formula will be 1 over RT equal to 1 over R1 plus 1 over R2 plus 1 over R3, and that keep going up until 1 over Rn. N is an integer here, so it can be any positive number. Okay, so this is a recap from there, and I hope we know how to identify parallel and series circuit. So this will be a series circuit, and series circuit is a circuit that has only one way for the current to flow, which is this way only. There is no other way to make that to complete that circuit back. So in the other hand, the parallel circuit is the circuit that has more than one path for the current to flow. So that is one path, that is two paths. So that's a parallel, that is series circuit. So R1, R2, R3, whatever, however you name these resistors will be totally up to us. And then we have to remember which one we did give numbers to, so because we don't want to have any confusion there. I hope that's clear. In a series circuit, if we have before we move into the solving the combination circuits, what we will have to do, we will try to, if you're solving this circuit right now, it has both, see, like we have a series right now, it's this branch. If you cut this piece out of here, it has a series circuit. If you cut this piece out of there, it has a parallel circuit too. So we have both of the circuits there, and we can, how to solve that, we will have to simplify this thing, solve this one first, this part of the circuit, and this will become once we do that, that will become such as that circuit. So that will be R1, and R2 plus R3 will be this one. Then we can solve this circuit in a series manner to find our current, and the voltage and everything is going. So we can start from the parallel, simplify them, rewrite the circuit, redraw the circuit, and then go from there. We will know this in next example. So let's move on to the example. Oh yeah, before the example we have some rules here. That's exactly what I said. Simplify the circuit. How we do that? Solve the parallel branches of the circuit first, which I said, like we have to solve it. Solve the parallel circuit, then draw new circuits, which we just did. Solve the simplified circuit. Then once you simplify this one, then you have to find the value of the circuits, whatever is missing, and assign new values to the component after solving. This will make sense once we solve this example here. So let's move on to the example. Let's use green color here. So the example says solve the following circuit. Okay, so that means we have to find the Ohm's law's component, which is we have already resistors, but we don't have V1, we don't have V2, we don't have V3, we do not have V4, and same is I1, I4, I2, I3, I4. We don't have these in IT also, and we will have to find RT2. So we have these many unknowns here. Let's move on and solve this example here. If we pay attention to this example, we have R1 is given, R2 is given, R3 is given, R4 is given. So that means we can find the RT here. Let's call R1 plus R2, call them Rn. Just I'm assigning number there, or you can say R1 plus 2. We can say that R1 plus R2 is equal to Rn, or in a general way we can say R1 plus R2. I like this notation, so it's not confusing. We don't have addition in the subscript. And let's call R3 plus R4 Rm. M as a Mary, or call it R3 plus R4. We have got to solve these two circuits first. We have to simplify them first to make a series circuit out of it. So for Rn, which is the parallel setting right here, let's use the general formula, which will be 1 over Rn is equal to 1 over R1 plus 1 over R2. Okay, 1 over Rn is R1 is 15, so it will be 1 over 15, and R2 is 25, will be 1 over 25. Add these together. I think 75 will do it. 75 will be our LCD here, because I found a number that can be divided by 25 and 15, and that should be the smallest number that we have possibly. So 75 divided by 15, we get 5. 5 times 1 is 5, plus 75 divided by 25 is 3, and time 1 is also 3. So 3 times 1 is 3, so it will be 8 over 75 equal to 1 over Rn. Now you flip these two fractions, we'll get Rn equal to 75 over 8. 75 divided by 8 is 9.375. So Rn will be equal to 9.375 ohm. And we had a rule in a parallel circuit: the total resistance should be lower than the lowest resistor we have. So 9.375 is lower than the lowest resistor in here, which is 15 ohm. So that works out. Now let's find Rn. Rn, Rm will be equal to, since it's a parallel to, let's see, 1 over Rm equal to 1 over R3 plus 1 over R4. Plug in the values here, will give me R3 is 10 ohm and R4 is 50 ohm. 1 over 10 ohm plus 1 over 50 ohm. So 1 over Rm is equal to, so the LCD will be 50. That will be 50. 50 divided by 10 is 5. 5 times 1 is 5. Plus 50 divided by 50 is 1. 1 times 1 is 1. So it'll give me 6 over 50. That is equal to 1 over Rm. And same thing, we will have to flip these two values. Those two fractions will give me Rm. Rm is the total for R3 and R4. So it'll give me 50 over 6. 50 over 6 is somewhere 8.34. 8.34 ohms. Okay, so since we found these two values right now let's redraw the circuit. Redraw the circuit. Okay, so the original circuit was we had two parallel settings and VT. So let's draw that. Will be, we found Rn. This is our Rn right now, 9.375, and we found Rm, and this is our Rm, which is 8.34 ohms, and Vt is given as 30 ohm. What is Vt? 10 ohm, 10 volts, sorry. Vt is given as 10 volt. Vt is 10 volts. To find now we have a resistance and a voltage, we can find the IT, or total current. So let's find that total current here. Let me need some space here. So to find IT, or total current, that will be Vt divided by RT. To find RT in this circuit, since it's a series circuit, we can just simply add them together. 8.34 plus 9.375 give me 17.715. 17.715. Okay, something is not right with my pencil. 17.715. Okay, so that's my RT. Now, since we got RT, we can move on and find IT actually. IT will be Vt is 10 volts divided by 17.715. 10 divided by 17.715. 17.715 will give me 0.56 amp, 0.56 amp. So IN will be 0.56 amp and IM will be 0.56 amp, because in series circuit the current stays the same and the voltage drops is the sum of the individual voltage. Okay, so we got I in there. We don't have I1 yet, we don't have I2 yet, but we got I1, I mean IN and IM. We got, so we got IT is a 0.56 amp, and we got IN, the current in this this resistor, which is the combination of R1 and R2, and we got a current in this resistor, which is in itself a combination of R3 and R4. We still have to find I1, I2, I3, I4 after we find the voltage drop in this series circuit, because we got the current, we got the total resistor, we got the resistance as the circuit, but we don't have a voltage now. Let's find the voltage in this at this point and voltage at this point. That should, a series circuit, the voltage drop in here, voltage drop in here, that should equal out with the 10 volts. Okay, so let's clear out some of the mess I made. Okay, so now our goal is to find Vn and Vm. So voltage at point N is equal to I N time R N. IN is 0.56 and RN is 9.37, so it will be 0.56 times 9.375. That will give me 0.56 divided by multiplied by 9.375. 0.7375 will give me 5.3.375 times 0.56 will give me that will be 5.25. Let's double check. 0.56 times 9.375, 525 volt. So the voltage drop here at Vn is 0.525. To find this voltage, you can simply subtract this number from the 10 volt, which will give me 4.75 volt. Hopefully we get the same answer as finding it by this way. So you can find it Vt minus Vn, which is 4.75 volt, because 10 minus 5.25 will give me 4.75 volts. Or we can find it in Ohm's law's formula, Im time Rm will give me 0.56 time 8.34. 0.56 time 8.34. 0.56 time 8.34. Give me 4.67. 4.67 volt. The error is in the rounding, because I had to round this number and I had to round this number too. Is in rounding. Okay, if you have a problem with the roundings, there is a video of mine in a math tutorial playlist. please go and refer to that video for the decimals. Hope that will help you guys. So okay, we found these Vm and Vn right now, which is the branch voltage. Let's move on to, we will keep this voltage 4.67 volt. This is the nominal voltage, but this is the calculated voltage. We will keep the calculated one. We will yes, if you have doing like just simply math, you'll have to get 4.75, but we did get this 4.67 from the mathematical expression here. We got everything we need here. Now let's move on and find out the I1 and I2, I3 and I4 right now. For that, we have to draw the circuit to the original setting. The original setting was okay. We have VT as 10 volt. We have RT. RT was what is RT? RT 17.715. 17.715 ohm. R1 is what was R1? 15 ohm. R2 is 25. 15 ohm. R2 is 25 ohm. R3 is 10 ohm. R4 is 50 ohm. We found the current dropping, and each IT was a 0.56 amp, and we found the voltage drop here in between these two branches, which is Vn is 5.25 volt, Vn which is equal to Vr1, and also in Vr2. They should be the same because these are parallel circuit. We got a V1 is 5.25 volt. Parallel circuit, the voltage stays the same. V2 is 5.25 volt also. Now the voltage drop between these 2 points, we had 4.67 volt, and we got V3 4.67 volt, and same things here. So we have what we need to find I1 and I2 and I3. To find I1, we need Ohm's law, Ohm's formula. So it'll be V1 over R1. Make that in mind that IT is 0.56. And the total current here should be adding up to 0.562. Let's see if that is correct. 5.25 divided by R1 is 15 ohm. Let's divide this thing. 5.25 divided by 15 will give me 0.35 amp. Let's find I2 will be V2 divided by R2. It'll give me V2 is same as 5.25 divided by 25 ohms. 5.25 divided by 25 will give me 0.21. 0.21 plus 0.335, and if you combine them together, it will give you 5.56. So yes, so that is actually the case here. Okay, so we got a I2 is 0.21 amp. Now let's find I3 here in a different color. I3 will be equal to V3 divided by R3. So V3 is 4.67 divided by 10. It will give me 0.467. 0.67 divided by 10 will be 0.467 amp, and I4 will be V4 divided by R4, which will give me 4.67 volt divided by 50. 4.67 divided by 50 will give me 0.0934 amp. If you add these, this one and this one should add up to 0.56. Let's see, 0.467. Yes, if you add these two, I3 plus I4 is giving me 0.5604 amperage. So that is actually correct, but the error 0.04 error is from the calculation or rounding issues here. So I think we got everything we needed. We found I1, which is 0.35 amp. We found I2, 0.21 amp. We got I3, 0.467 amp. And we got I4, 0.0934 amp. Okay, so these are all asked, and that's how we redraw the circuit and assign the value later. So I is 0.0934 here, and I3 you can plug it in right here, and I2, I1, everything is found. So this will be your end of this example. So please practice on the series and parallel circuit before we move on to the combination circuit, because it helps a lot to know the rules and the properties of both circuits there. So because we will have to use them genuinely here. And there will be next example. That example is already solved, but I will go through it and see how we do it. And then we have a couple more example, or maybe one more example to go through and finish this section with a combination circuit. Okay, so here is the example number 3. In example number 3, we will be solving this whole circuit. Remember, you have 3 sub-circuits here, and that's circuit number 1. It is the whole circuit, starting from here and coming back right here. So we got 3 circuits here too. And this is number 2. We gotta treat this as a separate circuit, and this is circuit number 3. So what we will do here, we will find the total resistance of these 2 separate circuits first. So since these are parallel circuit, we'll find the total resistance of this circuit and then this circuit. Then after finding that, we will go and redraw this circuit, having this only, and this whole circuit will become a series circuit because these two will combine and then we'll add here, and these two will combine, they will become here. So this will be the first step we do. So the good news is here is, like in this kind of questions, let's see what is given. VT is given, total voltage, or the supply voltage is given, 120 volt. It could be your home supply voltage, 120. Resistor number 1 is given, 2, 3, 4, 5, 6, and 7. They're all given, so we can easily find the total resistance once we find the individual total resistance from here and from there. So what is asked here, what to find? It is asked to find the current in each resistor and find the voltage in each resistor and total resistance, and that's how we start up. And these are given value right here. So yeah, as I said, like we have to simplify these circuits. In this case, I call these two addition of these two circuits Rn. Addition of these two resistors, I call them Rn. So R2, R3 is Rn, and R5, R6 is Rm. Rn, to add them, since these are parallel circuit, we go over this formula, which is the parallel circuit addition. 1 over Rn is equal to 1 over R2 plus 1 over R3. Then plug in the values here. Then find the LCD and just do the simple math for operation of fraction and addition. If you guys do have an issue with the fractions, please go and check my another video on fractions and operation on fraction, and it might under the method tutorial videos will help you. So once we do find the LCD and do the division and simplify it, after simplification we get a 1 over Rn equal to 5 over 1500. Then you reciprocate them, like flip them around, it will become Rn is equal to 1500 over 5, which will become 300 ohm. So Rn is 300 ohm, and in the same manner we will find 1 over Rm, and that is 1 over R5 plus 1 over R6. Plug in the values for each resistor, and you have a LCD right here. 1800 divided by 6 is 3, 3 times 1 is 3, 1800 divided by 9 is 2, 2 times 1 is 2, so 2 plus 3 is 5, 5 over 1800. Now you flip 1 over Rm, it will become Rm, and flip 5 over 1800 will become 1800 over 5. And the answer here will be Rm will be 360 ohm. Now once we found those values, we have to redraw the circuit. We have redraws. We have already given R1 is 150 ohm, and Rn, which is R2 and R3, we make it a new circuit right here. So this is our new circuit. This is our new resistance, this guy, and same with this one. These are our new resistance here. We got the values for all resistance. Now we can simply find RT, which is total resistance of the circuit. Total resistance in a series circuit, it is individually resistors added together. So 150 plus 300 will be 450. 450 will be 490, 590 will be 650, and will be 950 will be 1000, 1200. So you add them up and you'll get 1200 ohm for RT. Good news. We have RT 1200, we have VT 120 volt. We got two values. We can find amp and we can find the current from the Ohm's law. It says IT is equal to VT over RT. So 120 divided by 1200 will give me 0.1 amp. Right here, 0.1 amp. And notice one thing. So since we find 0.1 amp through this formula, which is Ohm laws right here, V is equal to I times R. If we want to find I, that will be divide both sides by R. I will be equal to V over R. That is the current formula when we have voltage and resistance. But it is series circuit, since we said in the beginning of the parallel circuit video that current stays the same all over the series circuit. So it's 0.1 amp here, 0.1 amp in Rn, 0.1 0.1 amp in R7 and every place. So that will make it easier. Now, since we find the IT, RT, and VT is already given. Now let's okay, so yeah, this is something I forgot. We got the R1 and I1, Rn and IN, but one thing are we missing because it's a series circuit. We have a different voltage drop in different places in the series circuit. Let's find that V1, Vn, V4, Vm, V7. So to find them, what we do, just use the Ohm's law as we said. V1 will be I1 times R1 and so on. V7 will be I7 times R7. V1 is 0.1 times 150 ohm, or 0.1 amp times 150 ohm will be 15 volts. Vrn will be 30 volts and V4 will be 0.100 times 140 ohm will be 14 volts. Vrm will be 36 volt and V7 will be 25 volt. Just using the Ohm's law here. Ohm's law. This is our best friend here. So, okay, now one thing we have to see. In the series circuits, the total voltage should be equal to the individual voltage, the individual voltage added together. So 15 plus 30 is 45, 45 plus 14 is 59, 59 plus 36 is 95, 95 plus 25 is 120 volts. So that adds up, which just proved their theory. Now since we found the individual voltages, now let's redraw that circuit to the original setting. So this was the original setting. R1 was given. This is R2, R3 is right here, R4 is here, R5 is here, R6 and R7. They're all given. Now we found the voltage in every point. The voltage drop at the V1 was 15 volts. We don't touch that because it's right there. Now voltage drop at this point right here is 30 volt. Is right here. It says like it is two screws. One wire is going this way, one wire is coming this way. So 30, it is a parallel circuit starting from here to here. It's a parallel circuit because we have a different route right now for the current to flow. So the voltage stays the same in this route, in this route. So 30 volts going this way, 30 volts going this way. So we have a voltage and we have resistance in the circuit. We can find the individual current in these two circuits, in these two resistors here. Same thing is true right here. We found the VRM or voltage endpoint was 36 volt, and that 36 volt is flowing here, and that same 36 volt is going this way too. So V6 has a 36 volt supply, and V5 also has a 36 volt supply, or you can say it like resistor 5 is taking 36 volt, and resistor 6 is taking 36 volt too. And since we have R5 and V5, we can find the individual current for this resistor and also that and that. But I7 should be still 0.1 amp, and I4 should be still 1.1 amp, and I1 is still 0.1 amp because that was still series circuit. Now we have this here as I have a R5 and R6 and R2 and R3. They are parallel branches. That's why the current goes. However, how many resistors have, it will be divided in between these two, where the numbers, whatever the number of the resistors is. So yes, the Vn is 30 volt, and that will be equal voltage at VR2 is equal to voltage at VR3. So this voltage and this voltage should be the same because the parallel circuit. Same is true for Vm. So now we can find I2, I3, I5, and I6. To do that, I2 will be equal to V2 over R2. V2 we said was 30 volt. We found it here. 30 volt divided by 500 ohm will give me 0.06 amp for I2. I3 will be using the ohms formula. V3 over R3 will be 30 volt divided by 750 ohm. Give me 0.04 amp. So we said IRM current drop at IM or this point was 0.1 amp. Since we divided this current into pieces, it's a parallel circuit. The voltage stays the same, the current goes into division. It divides itself into sources or the loads or the resistors. So if you add them together, they should give you back 0.1 amp, which will give you 6 and 4 is 1, and that will be 1 right here. And it's a decimal numbers. And if you guys have any problem with the decimal operation on decimal numbers, there is a video that I uploaded, or I will be uploading to math tutorial for the decimal numbers. Please go and check that. And don't forget to subscribe this channel for more helpful videos. Okay, so if I5 is a V5 over R5, after plugging in the value, we'll be giving 0.06 amp right here for I5 and 0.04 amp for I6. Combine them together, it will still give you 0.1 amp. So we found everything right here. Now we can just redraw the circuit and plug in all the values here. And this is the original circuit. The blue were the given value, and the white and red, that's the one we found out. So it wasn't that bad, right? So how was it, guys?
Not bad. Not bad at all.
Are we ready for a couple more examples? Yes.
I guess.
Okay, since you guys are ready, let's go to example number 3. And this example is relatively easy, easier than what we had before. I will solve this one, the easier one, then I will go a little bit complicated after that, and we will call that a day. So in this circuit, if you see, we are given the total voltage, resistor number 1, resistor number 2, and resistor number 3. So we only have 3 resistors, so that should not take a long time. But the asking values are here: RT, V1, V2, V3, I1, I2, I3, P1, P2, P3, and IT, and also PT. So they're all asked. So to start up, as we said, we have to simplify it. So we have 2 circuits here, one whole circuit, and this one, the sub-circuit. The parallel circuit will be the sub one. So we'll have to simplify that parallel circuit first, and find the total resistance for that. We will call R2 and R3 Rn. In this case, will be total resistor and total resistance for R2 and R3 plus R3. So this will be that. Let's find it. We can use the product over sum. So that will be R2 times R3 over R2 plus R3. That will be our Rn equal to, or we can find it this way, 1 over Rn equal to 1 over R2 plus 1 over R3. Okay, plug in value, we will go find it both way. R2 is 60 ohm time. Let's take this unit off of there, so no complication. And R3 is 40 and over the same value for addition. This will give us 6 times 4 will be 24, and we add two zeros will be 2400 over 100. You cancel these two zeros, will give me 24 ohms. So Rn will be 24 ohms. So let's plug it in here. What we get: R2 is 60 ohm, R3 is 40 ohm. Let's find the common divider, LCD, least common divider here. So that will be 2400 divided by 60 will give us what? Will give us 40, and 2400 divided by 40 will give us 60 times 1 will be 60. So that will be 100 divided by 2400. 1 over Rn is equal to 100 over 2400. So since we have two values, we can flip them around. We have both fractions here. So it will become Rn equal to 2400 over 100. Same thing, we can simplify this fraction. So 2400 divided by 100 will give me 24 ohm. So we found the Rn, or the total resistance for this sub-circuit. We will draw this new circuit here. That will be the positive terminal. So we got R1 and we got Rn, and that's all we have for now. And let's go on. R1 is 24 ohm. Rn is 24 ohm. Rn, which is R1, R2 plus R3, is 24 ohm. And V total, our supply voltage is 30 volts. We have both resistors in a series circuit. We can add them. Since we have another way of adding resistors in a series circuit, we just add them up. So RT will be here, R1 plus R2. So total resistance will be 48 ohm. So RT is 48 ohm. Now we have RT and VT. Let's find out IT, total current. Let's find total current. Once we find total current in the circuit, then we will find the individual voltage drop in this resistor, in this also in this resistor. Okay, let's go find out IT. I total will be from the Ohm's law will be VT over RT. VT is 30 volt divided by 48. 48 of 30 volt divided by 48 ohms will give me 30 divided by 48.625. 0.625 amp. Now, in the series circuit, the current stays the same in every point of the circuit. So I1 here is also 0.625 amp, and IN here is also 0.625 amp. Now we have IN and I1. Let's find voltage drop in each individual part of the circuit. So let's do a voltage drop with the red color. So V1 will be equal to R1 times I1, and that will give me, okay, so there is a R1 and I1 too. So R1 is 24 ohm times 0.625 amp. That will give me 24 times 0.625, give me 15 volts. 15 volts in resistor number 1. We can find the Vn, or voltage at point M. We can do it two ways. So 30 volts minus 15 volts will give me 15 volts, or we can just find it by the Ohm's law. Vn is equal to In times Rn. In is 0.625 times Rn is 24 ohm. So same value will still give me 15 volts. So in both ways we should get the, if you do it this way or Ohm's law's way, still get 15 volts there, because since we didn't do any rounding here, so we were pretty precise values here. We found this a couple components here. Let's go ahead and redraw that circuit to the original setting. So the original setting was, let's use a different color here, green color for the new circuit. Will be okay. So it was a R1, that will be R2, and here will be your R3. R1 was 24 ohm, the voltage drop was 15 volts, and I1 is 0.625 amp, and Rn or Vn here was 15 volt, and that is equal to, this is resistor number 2. Resistor number 2 was 60, and resistor number 3 was 40 ohm. 60 ohm, and R3 is 40 ohm. Okay, let's see if that is correct. Yes, 60 and 40 ohm. We found the voltage going into this Vn was 15 volts. And remember one thing, voltage drop in a parallel circuit stays the same. The voltage is the same at any point in the parallel circuit. So that's 15 volt is going this way, and it's also coming this way. So this will have a V2 will be 15 volts, and V3 will be 15 volts. So that will be 15 volts. Now we have to find the I3 and I2 here. And then we will worry about the power too. I2 will be equal to V2 over R2. I3 will be equal to V3 over R3. V2 is 15 divided by R2 is 60. 15 divided by 60 will give me 0.25 amps, and V3 is 15 divided by 40. 15 divided by 40 will give me 0.375 amps. So 0.375 amp. Now if you add I2 plus I3, that should give us 0.625 amp. Let's actually add them. I2 is 0.25 plus I3 is 0.375, and that will give me 0.625 amps. So that actually works out. I3 is 0.375 amps and I2 is 0.25 amps. The current coming into this node is going to divide in these two resistors. So 0.25 is going to resistor 2, 0.375 is coming to resistor number 3. Now we have found everything but the power. VT was given actually 30 volt. RT we found it. RT was which one was RT was 48 ohms. IT was 0.625 amp. And now we found I2 also is 0.25 amp and I3 also 0.375 amp. Now let's find power in each individual resistor and the total power also. Let's use white color here. So PT, find the total power. Since we have a I and we have a V, we can use this formula, which will be IT times VT. If we multiply IT is 0.625 times 30 will give me 18.75. It will be not 13, 18.75. It's power, so the unit of power is watts, watt. So total power in the circuit is 18.75 watts. Now let's find the individual power. P1 will be I1 times I1 times V1. I1 is here 0.625 times V1 is 15. 0.625 times 15 will give me 9.375 watts. P2 will give me I2 times V2. V2 is 15. Let's do the new, go by the number letter. So I2 is 0.25 times 15 times 15 will give me 3.75. So P2 will be 3.75 watts. And P3 will be I3 times V3. I3 is 0.375 times 15 volts. Not I3, sorry, P3 will be I3 times V3. I3 is 0.375 and V3 is 15 volt. So 0.375 times 15 will give me 5.625 5.625 watts. In a circuit, since we got the total power should be equal to the individual power there. So PT should be equaling to P1 plus P2 plus P3. Let's check this theory if it works here. P1 we got 9.37, 9.375 plus P2 was 3.75, P3 was 5.625. Let's see if we get 18.75. So 9.375 plus 3.75 plus 9.625. I got something different number here. Yes, because I plug in the wrong number. Yes, I got 18.75. If I add this number, 9, 3, 12, 12 and 5 is 17. 17, and you add these all together, we'll get 18.75 watts. So we were asked to find all the values, and the values were asked to find was RT. We found our total resistance, voltage drop at point 1, V2, V3, we found I1, I2, I3, and even the power at resistor 1, resistor 2, resistor 3, we found all and every individual component of the circuit. And we will have our very final example here. We will work on that, and then we will review it, and we will call the day for the combination circuit. The final example of this tutorial will be example number 4. It's asking for find the missing value of the following circuit. As we see, we have 9 resistors in the circuit, and total voltage is given. So we can, before we do anything with the circuit, we have to see how many branches of the circuit we have. We got a series connection going on to this point, then it's a split in a parallel circuit, then series, then parallel, then series. So we'll have to find the simplified circuit first, then we will find the RT, and move from there. So we will call these R2 plus R3, Rn, we will call them Rn. So 1 over Rn will be equal to 1 over R2 plus 1 over R3. We plug the value in here, 1 over 30 plus 1 over 50. The LCD will be 150. 150 divided by 30 will be 5. 5 times 1 is 5. Plus 150 divided by 50 will be 3. 3 times 1 is 3. So 1 over Rn will become 8 over 150. When we flip these together, Rn will become 150 divided by 8. 150 over 8 will give me 18.75 ohm. Now let's find the other parallel circuit. We have let's call R5, R6, and R7 Rm, and Rm is equal to R5, R6, and R7. Since it's a parallel setting, will be 1 over Rm equal to 1 over R5 plus 1 over R6 plus 1 over R7. Okay, so that'll give me the R50. So the count in the LCD will be 50. And it will become, because 50 divided by 1 is 1. 50 divided by 50 is 1. 1 times 1 is 1. And also 1 for the second. Also 1 for the third. So 1 over Rm will become 3 over 50. Well, we'll have to flip them to find Rm will be 50 divided by 3. 50 divided by 3 give me 16.67. Oh, okay, so we got these circuits ready, simplified. Let's redraw this circuit again. We found Rn and Rm also. That was the parallel. That were the parallel branches. Since we see all these values, we plugged in a series. Looks like a series circuit, and by definition, a series circuit is a circuit that has only one way for the current to flow. So we have that way is starting from R1, and we'll go all the way through Rn, R4, Rm, R8, R9, and all the way back to the battery's negative terminal. So let's find the RT here. RT will be the sum of all individual resistors. Will be 100 R1 plus Rn plus R4. Rn is 2 and 3. R4 plus Rm is 5, 6, and 7 plus R8 plus R9. We add them together and we get 100 plus 18.75 plus 90 plus 16.67 plus 600 plus 30. That will give me 855.42. 855.42 ohms. Okay, so we have a RT also, 855.42 ohms. Now let's find IT, or total current. IT will be equal to VT over RT. VT is 480 volts and RT is 855 ohms. So 480 divided by 855, that will give us roughly 480 divided by 855.42 will give me 0.56 amp. 0.56 amp. Okay, so let's see. Right now it's a series circuit, so the current here, 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 and this point, also here, this point, and this point, it will be all the same. So R1 and R1, R1 will be same 0.56 amp, and since we have the current the same and we have resistance at there, we can go ahead and find the voltage drop in each individual point. Let's find the VR1 will be, or we can say VR1 will be, let's not confuse it, we call it V1. Okay, V1 will be equal to I1 time R1. I1 is 0.56 time R1 is 100, and that will give me 56 volt. Now move on to Vn is equal to In time Rn. In is 0.56 time 18.75. 18.75 0.56 times 0.56 give me 10.5 volt. Now V4 is equal to 0.5. Okay, let's do it this way first. V4 is equal to I4 times R4. I4 times R4. I4 is 0.56 times R4 is 90. 90 times 0.56 give me 50.4 volts. Voltage at point M, Vm, will be equal to Im times Rm. Im is 0.56 amps times 16.67. 0.56 times 16.67 will give me 9.33 volts. Now R8 will be V8 will be I8 times R8. This is V8. So there will be 0.56 times 600. 0.56 times 600 will give me 336 volts. And V9 will be equal to I9 times R9. I9 is 0.56 times R9 is 30 ohm. 30, so that will give me 16.8 volts. Okay, so our total voltage supply was 480 volts. Our individual voltage should add up to the 480 volts because it's a series circuit. So it's roughly 56 will be 66, and 116, 125 become 126, will become 142, and that'll become almost 480 volts, which is correct for now. Now we will have to redraw this circuit. We will put the original circuit back there to make things easier. Okay. It's R1, R2, R4, It's R3, R5, R6, R7, R8, R9. Okay, so we found the circuit here. We redraw the circuit. We found the uh, values of the voltage V1, Vn, V4, Vm, V8, V9, and we also found the current in the circuit before. Here was a series circuit. We found the current. The total current was 0.56 amp. So it'll be same in this point, here, 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 and here. They all be the same because it's series circuit. So that means total current is equal to 0.56 amp. Will be same as a current at this point, current in this point, current in this point, current in this point, current in this point, and all the way to resistor 9. So we'll have all these current. The only one thing we don't have we don't have I2 and I3, I5, I6, and I7 because we have a collective current, not the individual current. We will find them too. Let's go. So if we look at this circuit right here, we have Vn is 10.5 volts, and this is a parallel circuit, so it branches out. One branch is 10.5 volt is going this way, and 10.5 volt is coming this way too. And same thing is true for here. 9.33 volt is going to R5, R6, and R7. So looking at that, we can find I2, I3, I5, I6, and I7. Let's find I2. I2 is equal to V2 divided by R2. Okay, V2 we say is equal to Vn, which is 10.5. 10.5 divided by R2 is 30. Will give me 0.35 amp. I3 will be equal to V3 over R3. V3 is equal to same as a Vn because it branches out from here. It would be 10.5 divided by 50. Will give me 0.21. So I2 and I3 will give me both together here. We said it was 0.56. If we add I2 and I3, it will give me 0.56 amp. But the individual current is and I2 is 0.35 amp and I3 is 0.21 amp. And I5 will be equal to V5 divided by R5. V5 is 9.33 volt because V5, V6, and V7 are equal to Vm because that's the parallel branches. It will be 9.33 volt divided by 50 ohm. So 9.33 divided by 50 will give me 1.886. Sorry, 0.886. 0.1886. Sorry, I think I'm a little bit tired. It's 0.1866. 0.1866 amp. We have the same resistance, all three resistors and the same voltage. So I5 will be I6 will be the same thing. V6 over R6 be 9.33 divided by 50 will give me 0.1866 amp. And same thing is true for I7, be 0.1866 amp. If you add these together, that should give me 0.56 amp. 0.5598. It's close enough to 0.56 amp because there might be rounding issues here. Okay, so we found individual current too. Now let's find if we can find the power in each point. First of all, we can find power as the total power. PT will be equal to, we will use the power formula, the IT time VT. We know IT is 0.56 amp time 480 volts. 480 times 0.56, it'll give me 268.8 watts. 268.8 watts. We can find the individual power. P1 is equal to I1 times V1. I1 is 0.56 amp times V1 is 56 volt. Point 0.56 times 56 volt will give me 31.36 watts for P1. P2, let's write down all these: P3, P4, P5, P6, P7 also. Okay, so at P2, we found the current at 2 was 0.35 and the voltage is 10.5. 0.35 times 10.5. 0.35 times 10.5 will give me 3.675 watts. 3.675 watts. P3 is I3 times V3. And I3 we found out was 0.21 and V3 is 10.5. 0.21 times 10.5. 10.5.21 will give me 2.205 watts. P4 will be 50.4 volts. It will be I4 times V4. I4 is 0.56 times V4 is 50.4. 0.56 times 50.4 will give me 28.224 watts. Okay, so I6, P6, P7, and P8, they should be the same because they got the same current and they got the same voltage. So they're all equal to same. They're same. We will find one will be 0.1866 times 9.33. 1.1866 times 9.33. 1.0 will be 1.7409 watts. And P8 will be, so that will be, okay, let's go for P8. P8 is 336, will be I8 times V8. I8 is 0.56 times 336. That was the voltage we had, 336 volts. Was it 336 volt? Yes. It'll give me 188.56 times 336. The sum will be 108. The product will be 188.16 watts, and power at 0.9 will be 16.8 volt. We have time 0.56. 0.56 times 16.8 times 16.8 will be 9.408 watts. If you add all these together, that should give you the total of 268.8 watts here. Let me double check with my math. 3.36 plus 3.675 plus 2.205 plus 28.224 plus 1.7409 plus 1.7409 plus 1.7409 plus 188.16 plus 9.408, 268.25. So we got roughly the same answer. I counted these 3 times because there's P5, P6, P7, they're all the same, so we have to do it 3 times, times 3. So these are all the value we found out. Hopefully these examples were helpful. Please practice on these examples. And try to review the series and parallel circuits too. And so far we solved almost 4 examples in this tutorial. And don't forget that in a series circuit, the current stays the same. The voltage drop is individual voltage drop. Their sum is equal to the supply voltage. In the series circuit, we simply add resistors together, while in parallel circuit, the voltage stays the same. The current drop is the sum of individual current that should be equal to the supply current, and we can find the resistors in 3 different ways. The more famous one is the reciprocal method. So please go ahead and go back to the series and parallel circuit, and then come back to combination circuit and practice them. And do not forget to subscribe this channel and I hope to see you next time when some more fun the electrical and electronic classes. Thank you.